All right, so today we're going to talk about dilations. The first question asks us, what is a dilation? A dilation is the image produced by enlarging or reducing a figure. So what is a dilation? A dilation is the image produced by enlarging or reducing a figure. A dilation is the image produced by enlarging or reducing a figure. Just like when you get light in your eyes dilate and make them all small. What is the center of dilation? Well, the center of dilation is a fixed point used for measurement when altering the size of a figure. All right, what is the center of dilation? It's a fixed point used for measurement when altering the size of a figure. When altering a size of a figure. Okay. What does enlargement mean? Well, it means to get bigger, but it also means that the dilation has a scale factor greater than 1. So an enlargement means the scale factor was greater than 1. What does a reduction mean? Well, that means smaller, and it means the scale factor is less than 1. All right, so to recap, an enlargement is a scale factor greater than 1. A reduction is a scale factor less than 1. All right, so we have all this talk of a scale factor, and it asks, well, what does the scale factor mean? What is it doing? Well, the scale factor tells us, 1, to multiply. To multiply. The scale factor tells us to multiply. This is what we're going to take the dilation by, to multiply. All righty, so let's look down here. It says, draw original figure in pen, center of dilation in marker, and new figure in pencil. All right, so we have a rectangle. It measures 2 by 3, and we're going to dilate using a scale factor of 3. So what that means is, first, this scale factor is greater than 1. And if you remember, for a scale factor greater than 1, it's going to be enlargement. So that means this figure is going to get bigger. So all we do is we take 2 and we multiply it by 3. 2 times 3 gives us 6 meters. So this side went from being 2 to being 6. Now 3 times 3 gives us 9 meters. So we have just dilated that figure. It went from being a 2 meter by 3 meter to now being a 6 meter by 9 meter. We have dilated that figure. All right, so let's talk about this one. It says dilating using a scale factor of 1/2. Uh-oh, warning sign should be going off in your head. A half, a half, a half. Well, that's less than 1. So what does this mean? Well, this means it's going to be a reduction. This poor little triangle is going to get smaller. So remember, scale factor just means to multiply. Well, if I don't want to multiply by a half, what could I use instead? Well, I could use 0.5 or 5/10. So I'm going to take each one of these numbers and multiply them by 0.5. Multiply them by 0.5. Multiply them by 0.5. And I get a new equilateral triangle of 4 meters by 4 meters by 4 meters. So I have now dilated it down to a smaller, reduced figure of 4 by 4 by 4. Now that's the easy stuff. You all know about that. So let's go ahead and flip over. And let's talk about what happens when they get into percents. Dilate the figure by enlarging the side by 40%. So is our figure getting bigger or smaller? Bigger because of that word enlarging. Now there's also something that we should take into account. 40% is our scale factor. This is how much bigger we are making it, by 40% bigger. Well, the trick here is to turn 40% into a decimal. 40% converted to a decimal. So convert to decimal is, move our decimal 2 times to the left, 0.2. It becomes 0.40 or 40 hundredths or 4/10. So we're going to multiply these each by 0.40, by 0.40. So that when we multiply it, we get 1 by 2. Wait a second, I thought it got bigger. Well, it does. 1.2 is not the measurement in the side. This means this is how much it's getting bigger by. So if it started off as 3 meters and we're enlarging it by 1.2 meters, our new side is 4.2. So our new square is 4.2 meters. Our new square is 4.2 meters. All right, for those people I lost, let's think about this again. All right. I had to make it bigger, hence the word enlarging. It was enlarged by 40%. So what I'm going to have to do, sorry, the lights went out in the classroom. All right, so what I'm going to have to do is 3 meters times 40 as a decimal, 40% as a decimal, I get 1.2. This is the original, the 3. This is how much we're enlarging it. We're enlarging it by 1.2 meters. This is the new. That is how we get 4.2. Okay, so I'm going to give you a second, actually a little bit more than a second. I'm going to ask you to do this second one by yourself. So let's try this second one by yourself. Dilate the figure by reducing the side 20%. Reducing. So is our figure getting bigger or is it getting smaller? It is getting smaller. Well, just like we did up here, we want to convert 20% to a decimal. So convert to decimal. Convert it to a decimal. All right, 1, 2. We get 0.20. That's how much we're reducing it. All right, so after we converted to a decimal, what did we do up here? Well, after we converted it to a decimal, we multiplied it by the original. All right, so I need to take this and I need to multiply it by my decimal. And when I multiply 1.5 times 2.0. Create my placeholder. I get 3. All right. So now I have 15 is my original. 3 is my reduction. So what is my new? Reduction. Does that mean I'm going to add that 3 to the 15? Or am I going to subtract? I'm going to want to subtract to make it smaller. So 12 is my new side. So my nice new equilateral triangle is a 12 meter by 12 meter by 12 meter. 12 meter by 12 meter by 12 meter. So again, to recap, convert to decimal, multiply by a scale factor, add it or subtract it, get your new. Convert to decimal, multiply by a scale factor, add it or subtract it, get your new. Finally, what happens if we have to find the scale factor? What happens when we have to find the scale factor? Well, that's easy. To find your scale factor, you put new over old. So new length or width over old length or width. Okay, so on the left, this is our old. On the right, this is our new. It went from being a 6 meter by 14 meter to being a 3 meter by 7 meter. Okay, so my new length, and you can pick either side. You can pick to work with 6 and 3 or 4 and 7. Well, my new length, let's pick the top, was 7 meters. My old length was 14 meters. And here is the answer of your scale factor. But what's wrong with that fraction? Well, we can simplify it. When we simplify 7 over 14, divide by 7, we get our scale factor as 1/2. Our scale factor as 1/2. So what that means is if I take 14 and I multiply it by 1/2, I get 7. And that is, in fact, correct. So was this an enlargement or a reduction? This was a reduction. This was a reduction. Which brings us to our next one. Now I'll go ahead and tell you, this is old. This is new. Figure it out.